Hello everyone, I am G. Shankar Varma of EC Department from Marri Laxman Reddy Institute of Technology and Management. Now I am going to teach a subject called electronic circuits, which is the extension subject of electronic device and circuits. So before going to learn about electronic circuits, we do have some prerequisite from electronic device and circuit subject. So this is the first lecture of electronic circuits. In this session, we are going to discuss about course objectives, course outcomes, course syllabus of electronic circuits. Apart from that, few topics from unit 1 also we are going to learn. That's what I have highlighted here. Those are the topics called classification of amplifiers, distortion amplifiers, different coupling schemes used in amplifiers, frequency response of an amplifier. So coming to the course objectives, the student will be able to design concepts of multi-stage amplifiers, design concepts of transistor amplifiers at high frequency, understand the concepts of feedback in amplifier circuits, distinguish between various multivibrators using transistors and sweep circuits, and also distinguish between various types of oscillators and large signal amplifiers. Coming to the next one, that is course outcomes. After successful completion of the course, students shall be able to analyze different types of amplifiers, operation and its characteristics. Understand the concepts of feedback in amplifier circuits, categorize different classes of power amplifiers and tuned amplifiers, design the concepts of transistor amplifier at high frequency. And also the student shall be able to illustrate multivibrators for various applications using transistor and sweep circuits. Coming to the syllabus of electronic circuit subject, the unit 1 covers multi-stage amplifiers. In this unit, students are going to learn about classification of amplifiers, distortion in amplifiers, different coupling schemes used in amplifiers, frequency response, and cascading, Darlington pair, transistor at high frequency analysis, etc. So in this lecture, we are going to learn about the first 4 topics from unit 1. Apart from that, unit 2, unit 3 mainly covers about the feedback in amplifiers. Actually, the feedback in amplifiers is classified into 2 types. One is negative feedback, second one is positive feedback. So second unit completely covers about negative feedback. Third unit completely covers about positive feedback, nothing but oscillators. Coming to the 4th unit, it mainly covers about large signal amplifiers, different types of large signal amplifiers and tuned amplifiers. Apart from that, the last unit, that is 5th unit, which mainly covers multivibrators. Apart from multivibrators, it also consists of time-based generators, various kinds of time-based generators. So these are the few textbooks and reference books that I have highlighted in this slide. So coming to the first topic of unit 1, that is the classification of amplifiers. If you observe this chart, the classification of amplifiers mainly divided into 5 types. First one is classification of amplifier based on frequency, classification based on operation, classification based on type of load connected, and classification based on interstage coupling. Coupling is nothing but connection. How we are going to connect 2 amplifiers, that is called interstage coupling. And the last one is based on type of application. So we will see one by one. First one is classification of amplifiers based on frequency. Again, under this topic, several kinds of amplifiers we are going to discuss. First one is the DC amplifier, where the amplification starts from 0 level. Coming to the second one, that is audio amplifier, where the amplification starts from 20 Hz to 20 kHz. And the third one is video amplifier, which amplifies video amplification from few kilohertz to hundreds of kilohertz. And the fourth one is radio amplifier, which amplification takes from megahertz to hundreds of megahertz. Coming to the last one, 5th one, that is ultra high frequency amplifier, where the amplification takes from hundreds of megahertz to some thousands of megahertz. So these are the amplifiers, different amplifiers based on frequency. Coming to the second classification, that is based on operation, it is divided into 4 types. So in this section, we are going to discuss about power amplifiers or large signal amplifiers. Nothing but our 4th unit is completely about this large signal amplifiers only. In our curriculum, we are having 4 types. Those are Class A, Class B, Class C and Class AB. Coming to the third kind of classification, that is based on type of load connected. Here we are going to discuss about 2 topics. Those are resistive load and capacitive load. Whenever we consider a electric circuit, we will take the output across either resistor or capacitor. That's why we have highlighted as resistive load and capacitive load. Coming to the 4th classification, that is based on interstage coupling. That means how we are going to connect 2 transistors. we have to follow some certain rules or some certain coupling or connection mechanisms. Those are, first one is direct type, next one is RC type, and third one is transformer coupled amplifiers. Next, fifth classification is based on type of application. So based on the application, again, here the amplifier is divided into 4 types. One is voltage amplifier, which amplifies only voltage level. Voltage level means, let us see an analog signal. If you observe from here, peak to peak, positive to negative, here this peak to peak distance is called amplitude. So whatever the amplifier which amplifies this peak to peak region, that is called voltage amplifier. So next one is current amplifier. Current amplifier means, again we will consider a sinusoidal wave. If we observe carefully, from positive to negative, this entire portion is called frequency or time period. The relation between time period and frequency is inversely proportional. So we call it as time period. So whatever the amplifier which amplifies this frequency level or time period level, that is called current amplifier. And the third one is power amplifier or large signal amplifier, which amplifies both this voltage level as well as frequency level or time period level. Tuned amplifier means, it first of all it selects a certain band of frequency and it will amplifies only that frequency. That is called tuned amplifier. So these are the different classification of amplifiers. Now we will see the another topic, that is distortion in amplifiers. So distortion means noise level present in the amplifiers. The output of amplifier come across with the following distortions that we highlighted here. First one is the amplitude distortion, next one is frequency distortion, third one is the delay distortion. Coming to the first one, amplitude distortion, we also call it as harmonic or nonlinear or voltage level distortion. If the output of amplifier having noise in voltage level or amplitude level, this type of distortion is called harmonic distortion. Coming to the second one, frequency distortion, if the output of amplifier having noise in frequency level, this type of distortion is called frequency distortion. Coming to the third one, phase or delay distortion, if the output of amplifier having noise in phase level, this type of distortion is called phase distortion. We will see again one by one. Let us assume this is our output wave. Let us assume this is our output wave and we are indicating the x-axis with frequency and y-axis with voltage, output voltage. Let us assume this is our expected wave from 0 to plus 5 volts actually we require, but additionally we are getting like this. So 12 volts actually we are getting, but we are expecting 10 volts. Extra 2 volts we are getting now. This is called distortion, amplitude kind of distortion. Let us consider this is called amplitude distortion. Let us assume another output signal again with frequency. We are expecting the frequency should be 10 seconds. But let us assume here we are getting 12 seconds. Okay. From here to here we are getting frequency as we are getting the frequency as 12 hertz. But we are expecting 10 hertz. So here distortion present at frequency level, then it is called the second type of distortion, that is frequency distortion. So apart from these two, amplitude and frequency, we are having another type of distortion that is called phase or delay distortion. We will see how it will present. Let us assume we are expecting a waveform like this. But apart from this, we are getting a waveform like this. So this means we are getting the output 180 degrees out of phase. That means there might be some distortion with respect to phase. This is called phase distortion or delay distortion. So coming to the next topic, that is different coupling schemes used in amplifiers. As we discussed earlier, coupling mechanism or connection mechanism is We have to follow these kind of mechanisms only to connect two different amplifiers. We are having total three schemes will be there. One is direct coupling. That means if we are connecting two amplifiers, there won't be presence of any kind of element. Directly we can connect two amplifiers. That is called direct coupling. Coming to the second one, that is RC coupling. That means if we are going to connect two amplifiers, we have to use the connection component as either resistor or capacitor. Coming to the third one, that is transformer coupling. Again, here if we want to connect two amplifiers, we have to use the connecting components as transformer between the two amplifiers, and we also collect the output across a transformer. So we'll see one by one. The first one is the direct coupling. If you observe this circuit, here we have directly connected the output of first circuit to input of second circuit. Q1 represents first transistor, Q2 represents second transistor. So how we are connecting? First stage or first amplifier output is connected as second stage or second amplifier input. Directly we have connected. In between these two, there won't be any elements. This kind of connection is called direct coupling. Coming to the frequency response, if we observe, see, in the middle region, there won't be any distortion. It is very flat. Surface is very flat. But if we keep on going to the higher frequencies, there might be presence of some distortion. That is one of the main disadvantage. And next one, this amplifier will allows the DC. And as we discussed, there might be no presence of any coupling components between these amplifiers. So that is about direct coupling. So coming to the next one, RC coupling. Here, first transistor output is connected as second transistor input with the help of a capacitor. So we can connect again two amplifiers with the help of either resistor or capacitor. Here we have used the capacitor. In the first case, we have seen some distortion across the frequency response. By using the RC coupling, we can avoid the distortion. And if you observe the frequency response, its surface is flat. There is no distortion at all. It is one of the advantage of this RC coupling scheme. And it will blocks the DC. First one, direct coupling, it does not blocks DC, it will allows DC. Because of the usage of capacitor in RC coupling, it will blocks the DC. We can consider it is one of the disadvantage. Coming to the last one, final one, that is transformer coupling used in multi-stage amplifiers. Here, one transistor output is connected as input to the second transistor with the help of a transformer, right? Transformer in general, we know that it is having a primary winding, secondary winding and all. So on the output also we have to connect across the transformer. So this is about transformer coupling. The main advantage with the transformer coupling is here impedance matching is possible. Whereas in direct coupling and RC coupling, impedance matching is not at all possible. Only in transformer coupling it is possible. That is the main advantage of transformer coupling. So if you observe the frequency response, it is also having some distortion. So that is one of the disadvantage, and it will blocks the DC. So coming to the final topic of this lecture, that is frequency response of an amplifier. So this is the frequency response of an amplifier. In the x-axis we have considered frequencies, y-axis we have considered gain. So what is a frequency response? If any question we get like this, what is the frequency response? Simply we have to write like a graph drawn between the frequency and gain, voltage gain in decibels. So from this graph, we have to identify some parameters. That is, first one is maximum gain. And after that 3 dB gain. What is 3 dB gain? Maximum gain minus 3 is called 3 dB gain. Let us assume we got the maximum gain value as 20 decibels. The 3 dB gain will be 20 minus 3, that is 17 decibels. If we observe carefully, the 3 dB gain line intersects the frequency response curve. And the starting frequencies where it intersects, we will consider it as lower cutoff frequency. At the higher frequency side, we will consider another frequency component that is called high frequency component. So there will be a formula for bandwidth, that is the difference between higher cutoff frequency and lower cutoff frequency. And one more question, what is the necessity of finding this bandwidth? See, if we purchased an amplifier and we want to know during which frequencies it is going to amplify. That means to know the operating range of an amplifier, it is necessary to find out the bandwidth of an amplifier. Okay. So here I have highlighted that point. The bandwidth is used to know the operating range of an amplifier. Without knowing the operating range, we are not able to perform this amplification operation. So that's all for today. So this is about few basic concepts in Unit 1. In the coming lectures, we will see more topics from Unit 1 in the subject electronic circuits. Thank you.